I'm Lisa Goddard, and I'm a research scientist at the IRI at Columbia University. Obviously, it's the variability, the year-to-year changes in the climate that really affect people the most, and decisions and things like that. It's obvious that interests should turn towards, how is this variability likely to change in the future? How are our year-to-year impacts going to change in the future? So there's a lot of research going on, and I think there's still some debate. One thing that we've learned is that although there are, say, about 24 models from around the world that contribute to the IPCC projections, only a small handful of those actually have been deemed to reproduce ENSO realistically, which means that they have a realistic amplitude of ENSO, that ENSO events tend to grow at the correct time of year because El Niño and La Niña events do have a seasonality to them. The strongest sea surface temperature anomalies are near the end of the year. The interactions between the ocean and the atmosphere that are central to the ENSO phenomenon, how well that's done in the models. You end up with 4 or 5 of those 24 models that really do a good job at reproducing, at simulating ENSO-like variability. So the difficulty in looking to the future has to do with the variability of this variability. One thing that many people, especially in places that are impacted by El Niño or La Niña, will recognize is that not all events are the same. You have larger events, you have smaller events, you have events that may be focused in farther to the east of the Pacific or more in the central part of the Pacific, and those differences translate into differences in the impacts that are felt in different parts of the world. Because there is so much variability from event to event, and this is something that happens every 4 to 7 years, it's very difficult to actually say with certainty that the changes that you're seeing in ENSO variability are due to changing greenhouse gases as opposed to just part of the variability. The conclusions that I'm coming up with do deviate somewhat from what the IPCC says, although the last IPCC report actually says very little about how ENSO is likely to change. But the impression has been that some models say this, maybe they say La Niña events and El Niño events will become stronger or more frequent, and then you have another group of models that says the opposite, and so people say, well, we can't conclude anything because the models all disagree with each other. But actually, if you look at a single model, that single model will say there's no discernible change. And if you do that in the models that contain ENSO realistically, the conclusion is there's no discernible change, which is quite a bit different than saying that there is discernible change in individual models, but they just disagree. And so I think that's part of the difficulty is what information people are actually using to assess whether or not ENSO is likely to change. So you need to start with models that contain ENSO phenomenon in the first place. Otherwise, if you're not reproducing the situation, if you're not reproducing the processes, there's no way that you can determine how those processes are likely to change.